Now we're going to introduce the topic of arrays. To do that, I'm going to use a problem. So let's say that what we wish to do is to write a program that stores a student's individual grades and then find the maximum of those grades. So I might have something like this. Int G1 equals 68, G2 is equal to 73, G3 is equal to 90, and G4 is equal to 81. So the student has 4 grades. They're all going to be integers in most cases. So these are the 4 grades. And then we want a max variable because we want to find the biggest of these. And so I'm going to say int max equals 0. So why initialize to 0? Well, one, I know that all grades are typically greater than or equal to 0. So certainly max can't be less than this. And what I'll do is, starting with G1, I'm going to compare it to the current max, which is 0. And since 68 is bigger than 0, then the max up to this point in the process will be 68. And then I'm going to take 73 and compare that to the max. And since 73 is bigger than 68, max is now going to be 73. Move to 90. Is 90 bigger than max? Yes, because it's bigger than 73. So max is now 90. Move to 81. Is that bigger than max? No, because 81 is less than 90. And then whatever my final value is what I'm going to print. Oops. So eventually I'm going to do this. Maximum grade is %D. And now if I write the logic to find out what the max is, I'm going to say if G1 is greater than max, max equals G1. At this point, max will be 68. And now I can change G1 to G2. Change this to G3. And finally, change this to G4. So let's see if that works. So the maximum grade is 90. So that's the correct answer. Was this that difficult to do? Not really. I mean, the logic wasn't difficult and it didn't really take that much typing. But imagine I had 1,000 numbers that I need to process. Am I going to create 1,000 variables and then write 1,000 if statements, checking each of those variables to see if it's greater than the current value of max? I could, but obviously that would be a tremendous amount of work. So there has to be an easier way. Now, one of the things I notice here is I keep asking a question over and over again. Is one of the particular grades greater than the max? And if it is, make the max equal to that current grade. So when I start thinking about my programming elements that allow me to repeat a process, I think of loops. But then I run into another problem. I certainly can write a loop, and I actually could write a loop to do what I just described. But how do I write a loop to say on the first iteration, use G1, on the second iteration, use G2, on the third iteration, use G3? I could do that with a bunch of extra conditionals that now check to see which number I should be using. But that's actually more work than just doing this. So that doesn't help me. So clearly there has to be a better way. And it turns out there is by using something called an array. So just as we can store values in single variables like I did here, we can store multiple values of the same type in an array. And then that allows us to easily navigate through the array to where on each iteration of our loop we can say, okay, give us the first element of the array this time, give us the second element, give us the third element, and so forth. So if you know what a vector in mathematics is, then a one-dimensional array is going to look similar to that. So here's a vector x with 3 values, or 3 elements, 3.5, 4.0, 9.34. And then the way I refer to the first element is to use x1. So x1 is equal to 3.5, x2 is 4.0, and x3 is equal to 9.34. When we wanted to store an individual int, then I'd write something like this, int some variable. And what this did was allocate enough memory for a variable type int and then interpret the bit pattern as being an int. But what it did not do in this case is initialize that spot memory. So remember, we said that we should assume that in this case some variable contains a garbage value. Well, if I want to allocate enough memory to store 10 ints, then the syntax for this is this. All the variables will be type int. I have an array name, some array, and then in square brackets here I put a 10. But just like what we said here, these are uninitialized if I write this. So I should assume all 10 values are currently garbage. So let's see this in action. So here I decided to create an array called SumData of type double, and I allocate memory to store 3 doubles. And then later on in my program I want to put those initial values. So these are actually the 3 values that I had in my vector. But notice that unlike before, where the first number here was at index 1, in an array in C, the first index is 0. So out of these 3 positions, the first index is 0, the second is 1, and the third is 2. So SumData 0 is 3.5, SumData 1 is now 4.0, SumData 2 is 9.34. You can think of these names, or these, the way I've written here, SumData 0, as being the name for that first spot in memory. SumData 1 is the name for the second spot. SumData 2 is the name of the third spot. I could have written double A, double B, double C, and those would have been the names. But then we would have ran into this problem over here where it's difficult to navigate through them easily. With this, as we'll see, I can navigate through these because what changes each time? The index. And this is just a sequence of numbers starting at 0. Now, in many cases, especially at this point in our lecture series, since we don't know how to read from files, we'll just hard code the data in our program. So at the time I write the code, I already know what the 3 numbers need to be. So instead of doing this, which I could, it's actually easier to come down and do this all at once. Now what you may notice is I left the square brackets empty here because whenever I create an array, in some form I have to let the computer know how much memory to allocate. That is, how many values will I store in my array and what type will be those values. Up here I explicitly put 3. But down here, since I gave it 3 values and left the square brackets empty, then it will count the 3 values and know I want enough memory just to store those 3 values. So I don't need to write the 3, although I could. Now, if I knew that I actually wanted to store a total of 7 values, but I only knew the first 3, then I'd put 7 here. All right? So now let's see how we can use an array. So here I've created an array of type double that stores my 3 numbers. And notice now if I want to print the last one, 9.34, I just refer to it as my data 2. Just like I said before, if I'd called these A, B, and C, and I want to print 9.34, I would have put C here. Well, now the name for that spot in memory is my data 2. And just like if I'd said double C equals 9.34, I could change C. Well, then I can change my data 2. So now I change this spot in memory to contain 6, and so when I print what's my data 2, I see 6 here. So just a reminder, each element of the array will be of the same type. Everything here is a double. So I can't make this array such that this is an int and this is a double and this is a char. Not in the sense you might think. The indices start at 0. Some programming languages do start indices at 1, but not here. And then one of the most common bugs you'll see when dealing with an array can be explained in different ways, but some programming or compilers will say something like array out of bounds. So what does that mean? What it means is I've attempted to change values outside the actual array. So because these are indexed as 0, 1, and 2, but there's 3 values here, a common mistake would be trying to work with my data 3, but there is no my data 3. So let's see what could happen if I tried that. So I wrote a program here in which I stored 3 ints, and I've explicitly said 3 here, although I could have left this out and it won't affect anything. And now I have a loop that starts at 0, So I can print the 6 and then it increments to 1, so I can print the 9 and so forth. But I made a mistake right here. My loop runs too long. I should have said I less than 3, so that way the last value of I that I use would be the 2 for the position where 12 is at. But I mistakenly go all the way to 3. So I try to print 4 numbers. Now it turns out that actually won't cause a problem because I can look at other memory locations typically. The problem is then when I try to change it. So when I come down here and say data 3 equals 8, which would be in the memory position after 12, I shouldn't be doing that. So when I compiled that code and ran it on using Visual Studio, I got this error. Here's where I'm printing the 4 values, 6, 9, and 12. But then when I printed data 3 right here, there is no data 3, so I printed whatever was at that position in memory. And so notice it's essentially some garbage value. I don't know what's going to be here, but it's this really large negative number. However, when I got to data 3 equals 8, that's then when I had what's called a runtime error. The program compiled, and typically in C, the compiler's not going to catch that type of mistake, although there are tools that would try to help you out on that. But runtime errors where then I run the program and it crashes, telling me I did something I shouldn't have been doing. But one of the things to keep in mind is that sometimes I could have ran this program and there wouldn't have been a runtime error. So sometimes it happens, sometimes it doesn't, which makes it a very difficult bug to track down. So now that we know how to use a loop to process numbers, let's go back and fix our program. So now I'm going to create an array of type int, because these are all ints. Let's call these just G. And because I'm going to give it all the numbers to be stored, I'm going to leave these square brackets empty. And now I'm putting here 68, 73, 90, 81. We don't need this anymore. And now what I'm going to do is write for I, and I need the I variable, I equals 0, I less than 4 in this case, I plus plus, int I, we need that variable. And now, since I'm going to process G0, G1, G2, G3, then down here I need to compare G sub I to max, and if it's bigger than max, change max to be G sub I. So now let's see what we get. So I'll still get 90, but with less effort. So you may say, well, okay, you had those 4 if statements, and that really wasn't much different than this. Well, what if we did this? So let's say I add 4 more numbers. 86, 95, 47, and 50. I can change this to 8. Eventually we'll see a way to automatically determine how many numbers are here, and I won't have to change this. I'll store it in a variable, and then if I add or remove numbers and recompile, then my variable will just pick up the correct count. But for right now, we'll write it that way. So I can see here 95 is the new max, and that's what we get. So I would argue this is much simpler than writing a whole bunch of if statements. And of course, if I read this in from a file, I may not even have to explicitly write the numbers. I just read them in from the file without much work, and it's certainly much easier. All right. So what are we doing here? Now I'm going to allocate enough memory to store 4 ints, but I only give it the first 2 values. So in C89, I can give it some of the values of the array, but they have to be in the first X number of positions. I can't specify that this is the last value and this is the 4th value or whatever. This will automatically be data 0 and this will be data 1. All right? And then I don't specify what the other 2 are. And then later on in my program, I come down here and say, okay, the last position, which will be data 3, I give it a value of 3. And now when I print the 4 positions in data, this array, what do I get? I get 6, I get 94, I get 0 for the 3rd one, and then I get the 3. So where did the 0 come from? If I'd written int data square bracket 4 square bracket semicolon, then the array would be uninitialized, and I should assume that I have garbage values. But if I put a number in here to initialize any of the array positions, all the remaining array positions that I've allocated memory for will be initialized to 0. And that's what happened here. So that's what I'm telling you here. So let's look and see an example of that. So there's lots of times I want to do something like this. Looks like we need about half that. So there's times that I would have a counter for something. So I'm going to have a variable called counter. And typically counters start at 0 because we say, well, initially nothing has happened. And then after it's happened once, my counter goes to 1. After it's happened the second time, my counter goes to 2 and so forth. And I would do this. But what if I have 10 counters? Well, I don't want to call those counter 1, counter 2, counter 3 in most cases. Instead, I can just use an array. So I put my 10 in here. And then what do I use over here? Well, I can do this. Oops. So I want to see what index I'm on, and then let's print the number at that index. All zeros. But let's be clear what I wrote here. This isn't saying initialize everything to a 0. What it's saying is put a 0 in the first position in the array, and then for the remaining 9 that I haven't initialized, let those default to 0. So if I come up here and change this to 99 and rerun the program, you can see I got 99 in the first position, and then the others default to 0. All right, so I could have done something like this. There's those 3 numbers, then everything else is 0. So I know these will be zeros. But once again, writing this doesn't say just put a 0 everywhere. Now I could come in here and explicitly type in a 0 for everything if I want to, but there's no reason to in this case. So let's stop this video here, and then I'll create another video on arrays after this.